Um, close.
It should be closed. Then and then you can apply. And which sum we are doing
Yes.
in KCL and KVL? The word is there. Which summation we are doing?
Yeah.
Algebraic.
Node.
We are doing algebraic summation. So
Algebraic summation.
the algebraic summation word is very important for to define KVL and KCL. Okay, so in KVL and KCL, as we are using DC source, so in DC source, just we have only one type of resistor. Mostly, we are using resistive type of load in a DC circuit. So when we apply KVL and KCL, we are doing algebraic summations. Okay, so I can write this algebraic summation. Okay, algebraic summation. So in KCL, for incoming current, it is denoted by which sign?
Positive.
Yes, it is denoted by positive sign. And for leaving current or outgoing current from the junction, then it is denoted by
Negative.
is denoted by negative sign. So in any closed path of circuit, the algebraic sum of all the currents meeting at a junction is zero. Or in other words, it states that sum of entering equal to sum of leaving current at a node. Okay, so this is KCL. Suppose I am giving one task. I have two branch. This is my R1. This is my R2. This is my R3. This is my R4. Okay, it should be closed. I am giving IS supply. IS. This is my R1, R2, R3, R4. This is we have two branches. So this is my I1. This is my I2. Okay, I have one node or junction. Suppose I want to apply KCL, then what will be the equation?
Is equals to I1 plus I2.
Yes, so IS is incoming current, I1 is outgoing, I2 is also outgoing. So IS is equal to I1 plus I2. Suppose I am having R1 is equal to R2 is equal to 1 kilo ohm, and R3 is equal to R4 is equal to 100 ohm. Okay. Suppose IS is 50 ampere, and then I1 will be something 46, and this is 4. Okay. So it is around, both are 50. Okay. So this is the KCL, because KCL that follows the law of conservation of energy. Law of conservation of, is it visible, this what I am writing?
Yes,
Yes.
sir.
Okay, so it
Yes,
follows the
sir.
Yes, sir.
law of fall of conservation of energy. So energy neither be created nor be destroyed. It can be transformed from one form to another form. So whatever supply current we are giving to the circuit, so that we are getting in terms of output. Okay. Same in KVL. Whatever supply is given to the circuit, so in terms of output, that total voltage we are getting in terms of output. So KVL and KCL, that both laws following the law of conservation of energy. Okay, so why we are getting here 46? Suppose approximately here I have written 46, and here I have written 4. So what is this difference, 46 plus 4? Why I am not getting 25 plus 25?
Difference in resistance in two branches.
Difference in resistance.
Because
Yeah.
resistances are different.
Yeah, so here we have 1 kilo ohm, and here we have 100 ohm. So due to this difference in resistor, we are getting the different current. Okay. Then we discuss KVL. Okay. So KVL again, it states that in any closed path of circuit, the algebraic sum of potential difference in any loop must be equal to 0, sigma equal to 0, or I can write sigma IR plus sigma EMF is equal to 0. This EMF, that is electromotive force, that is your source, that is supplied by battery. Okay. So the EMF that is you are giving by the battery, so that is your EMF source. So it can be defined in other words, the algebraic sum of product of current and resistance plus algebraic sum of EMF is equal to 0. Okay. Suppose I am giving one. Also, we discuss some rules. Okay. So in rules, we discuss we are moving or we are traveling in positive to negative, so there is fall in voltage. Okay, there is fall in voltage. If so, fall in voltage, it is denoted by negative sign. Okay, if we are moving negative to positive, then there is
Positive.
rise in voltage.
Rise
There
in
is
voltage.
rise in voltage, so denoted by positive sign. If we
Positive.
are moving or if we are going through resistor in same direction, then there is
Positive.
no, there is fall in voltage. We are moving through resistor in same direction, so there is fall in voltage, negative sign. If we are moving through resistor in opposite direction, then there is rise in voltage. So it is denoted by positive sign. So these rules you should remember while applying KVL in the circuit. Okay. I'm giving one example so that these rules you have to apply for KVL in particular circuit. So I'm giving one example. Suppose I am having one resistor, one EMF source here. Again, I am having one resistor, one more resistor, one second EMF source. Then I am drawing one more resistor here. All are connected in parallel. So just I am extending the circuit. Okay, so just I am giving the name. This is my E1 source. This is I am giving R4. Okay, the current for I4 is like this. This is my R1. This is my I1. Okay, this is I2, R2. This is E2, R3, and I3. My loop direction is like this. You have to apply. So starting with R1, apply the KVL. According to sigma IR plus sigma EMF is equal to 0.
Minus I1 R1.
Yes, minus I1 R1. Then
Minus I2
Minus I2 R2. Minus I2 R2.
yes, minus I1 R1 minus I2 R2.
2R minus
minus E2.
Minus E2.
Minus E2.
Yes, minus E2. We are traveling positive, negative. So for EMF source E2,
plus
negative.
I3 plus R3.
Plus I3.
Plus I3 R3.
Resistor in opposite direction for R3. So that is your plus I3 R3 for E1.
Plus
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 E1.
plus
Plus E1.
Yes, it is
minus I4 R4.
minus
Okay,
I4
okay.
Minus I4.
Yes, sorry. Here I4 is remaining. So just I am writing here minus I4 just I lost my pointer here. So have you understood this? This is minus I4 R4, okay? Just I lost my
Yes, sir.
pointer.
Yes, sir.
So equation again. So minus this just I lost my pointer. My equation is okay minus I1 R1 minus I2 R2 minus E2 plus I3 R3 plus E1 minus I4 R4 is equal to 0. So that is your KVL. Okay. So these are the rules that we discussed. So some of the definitions are given. Before that, just we are moving to the series and parallel connection. So you already know series and parallel connections. Okay, you should know the equivalent resistance equations for series and parallel connections, the applications of series and parallel connection, and how to solve series and parallel circuit examples. Then we will move this mesh and nodal. Okay, so series connection, you know, if series resistors are connected in series, then R equivalent is given by R1 plus R2 plus R3. So as we know, in series connections, current remains same as and voltage remains different. So I can write series connection. Mute from your side. Mute from your side. So in series connection, current remains same. So and voltage remains different. So I can write here according to equations. Okay, just I am starting again. Okay, so suppose I am applying V is equal to V1 plus V2 plus V3. So V1 across R1, V2 across R3, V3 across R3. So according to Ohm's law, V is equal to IR is equal to IR1 plus IR2 plus IR3. Why I have written here same I? Why I'm not writing I1, I2, I3?
In series current
Because
is
Yes,
same.
Series current
remains
current
same.
remains same.
Current is same in series.
Yes. So this is IR. I'm taking I common R1 plus R2 plus R3. Okay, so I cancel. So R equivalent, that is R1 plus R2 plus R3. Okay. In parallel connections, voltage remains same, whereas this is for our series connection. Okay, now for parallel connection, suppose we have having three resistor in parallel. So voltage remains same, current remains different. So I can write I is equal to I1 plus I2 plus I3. According to Ohm's law, I is equal to V by R. This is our V by R1, V by R2, and this is V by R3. So by taking V common, we have R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay. In series connection, the equivalent resistance is greater than the greatest resistance connected in series connection. Suppose R1 is equal to 1, R2 is equal to 3, and R3 is equal to 5. R equal values are in ohm, so 9 ohm. So the R equivalent is greater than greatest resistance connected in series connection. In parallel connections, suppose we are taking same example. So in parallel connection, R equivalent is less than the least resistance connected in parallel connection. Tell me the R equivalent for this parallel connection. In parallel connection, R equivalent is less than the least resistance connected in parallel connection. So it will be less than 1 ohm. Are you getting less than 1 ohm?
Yes.
Yes.
What is the value?
Yes, sir.
What you are getting?
0.6.
15 by 20.
Point?
0.65.
15 by 23.
Okay, 0.65 ohm. Okay, so you can see here the in parallel connection than the least resistance connected in parallel connection, whereas in series connection, R equivalent is greater than the greatest resistance connected in series connections. Okay. Now we are moving to the series and parallel connections. Okay, slide number 32. So this is the equations for R equivalent. Okay, so that you are going to apply in example for solving R equivalent resistance. By finding R equivalent resistance, you can find total circuit current or supply voltage. Okay. So number of resistance are connected. Then suppose you want to find the circuit current, then you need to find R equivalent. Okay, in either series or parallel connection. Then you can find total circuit current. If you need to find any resistor or any unknown resistor, then you can use this formula for finding. We have passive elements, capacitor, resistor, inductor. Suppose we are applying series and parallel connection, then for capacitor it is reverse. Okay. In series connection, capacitor that can be written as 1 upon C is equal to 1 upon C1 plus 1 upon C2. For this, okay, for series connection in capacitor, that we will see in electrostatic chapter. We will prove these equations. In the resistor, it can be written as R is equal to R1 plus R2, and for inductor, it can be written as L is equal to L1 plus L2. So this we will study in electromagnetics. In parallel, for capacitor, C is equal to C1 plus C2. For resistor, 1 upon R is equal to 1 upon R1 plus 1 upon R2. And for inductor, 1 upon L is equal to 1 upon L1 plus L2. Now suppose we want to find change in voltage, then the fundamental formula for finding this delta V is equal to Q by C. For resistor, that I into R, and for inductor minus L di by dt. Okay, so this is the series and parallel formula for all three elements, resistor, capacitor and inductor. Now we are focusing on the resistor. Okay, in capacitor we will see in electrostatic, for inductor we will see in electromagnetics in detail. Suppose this before going for examples, you should know some advantages and disadvantages and applications of series connections. So in disadvantages of series circuit, if any failure or break occurs in circuit, current will not flow. Okay, so due to that your entire circuit becomes useless. In series circuit, if any break or failure occurs in circuit, so no current will flow. So entire circuit becomes useless. Suppose we have three lamps. Suppose we have three lamps. Suppose we have three lamps, each rated 230 volt. So 230 into 3 is equal to 690 volt. Okay, but our supply voltage is only 230 volt. Okay, so due to that, for domestic purpose or for wiring connection, for practical applications, series circuit is not applicable for domestic and power wiring connection. Okay, because we are connecting the appliances in series. So due to this rated voltage becomes more than the supply voltage. So it is not used for domestic appliances connection or power wiring connection. Okay. It is used in series connection. Suppose we want to connect a regulator with fan, so it is connected in series. Okay. The applications for series connection is connected with fan in series. And second application is low voltage lamp. Low voltage lamp used for decorative purpose. So low voltage lamp that having the less voltage requirement. Okay, so that can we can connect across the supply voltage. Okay, so low voltage lamp or series lighting that is used for decorative purpose, that is used in series connection. So this is the practical applications of series connection, while it is not used for domestic or power wiring connection. Okay, why? Because this is the main drawback. It is connected in series, so it is in add up. V is equal to V1 plus V2 plus V3. So rated voltage that becomes greater than the supply voltage. Okay, so this is the drawback of series connection. Now practical parallel connections advantages. So there are a number of advantages of parallel connections. So in parallel connection, what happen? The electrical appliance is rated for same voltage. Okay. Anyone having doubt in series connections?
No, sir.
No.
Okay, so in parallel connection, okay, in parallel connection, the electrical appliance is rated for same voltage. Okay, electrical appliances, we have electrical appliances rated for same voltage. So here rating is same for each appliances, but what is the main difference? Main difference is power rating is different. Power rating is different. So in parallel connection, we can connect electrical appliances rated for same voltage, but different power rating appliances that can perform without affecting the other appliances. Okay. Suppose we are connecting one bulb 100 watt, second bulb 60 watt, third bulb is 10 watt. Okay. So each bulb rated voltage is 230 volt, but power rating is different. So according to power rating, it will consume the power. Okay, according to P is equal to I square R, okay, or P is equal to VI, it will consume the power. But the rated voltage is 230 volt. Okay, so this is the main advantage. This is the main advantages of parallel connections. So we can connect the number of electrical appliances rated for same voltage, but due to different power rating, it can perform without affecting the other appliances. Okay, if any break or failure occurs in any branch of the circuit, so it will have no effect on the other branch of appliances, as a number of appliances, suppose this is our first lamp, this is our second lamp, this is our third lamp. Okay, so if a failure occurs in any of the branch, then it will have no effect on the other branch of the circuit. Okay, so this is the main advantage of parallel connections. And due to these advantages, all electrical appliances are connected in parallel. We can switch on and off any appliances or lights without affecting other appliances. Okay, so all all domestic and power wiring connection are connected in parallel because because that the working voltage of each appliance is equal to is equal to supply voltage, but the power rating is different. Okay, so anyone having doubt in parallel connection, why it is connected, why it is used for domestic purpose or power wiring connection?
No, sir, no doubt.
Okay, the
No,
main
sir, no.
advantage is that is rated for same voltage, but the power rating is different. If any break or failure occurs in any branch of the circuit, so it haven't any effect on other branches. Okay, and which we can switch on or off any appliances without affecting the other appliances. So this is the main advantages of parallel connection. The applications is domestic and power wiring connections. Okay. Now we are moving to the example. So determine the value of R so that the current supplied by the battery is 5 ampere. So here number of resistors are connected in series and parallel form. Here one unknown resistor are connected and it is supplied by 15 volt. Okay, so here we need to find this unknown resistor R. So what we will do in first step? First step, solve this parallel connection. First, solve these parallel connections. I am giving this for parallel connection. I am giving 1 upon R1. So 1 upon R1. Suppose I am giving 1 upon 4, 1 upon 10, and 1 upon 20. So R1 is equal to anyone?
2.5.
R1 is equal to
2.5.
0.04.
2.5.
is okay. Two students are getting 2.5.
2.5. 5 by 2.
Answer is 2.5. Okay. Answer is 2.5.
2.5.
Now in second step, solve these parallel connections. So I am giving the name 1 upon R2 is equal to,
1.2.
okay, wait,
1.2.
1 upon 3. So R2 is equal to,
1.2.
answer is 1.2. Okay. Answer is 1.2 ohm. Now, what we are having in the circuit? 2.5 ohm, 1.2 ohm, and this 2.3 ohm are connected in series. So that is 6 ohm. Now 6 ohm connected in parallel with R. So suppose I have R equivalent, then R equivalent or total circuit resistance that is given by the 6 ohm and R connected in parallel combinations. So I have total resistance of the circuit 6 parallel with R. So I can write 6 into R divided by R plus 6. Okay. First, I need to find this total resistance of the circuit. So current is given, voltage is given. So I can find total resistance, that is V by R. So 15. Here I can write here 15 by 5, that is 3 ohm. 5, that is your current. Okay, so total resistance is 3 ohm. Now substituting in this formula, 6R upon R plus 6 is equal to 3. So R is equal to 6 ohm. Are you getting?
Yes.
Yes, sir.
Yes,
So
sir.
anyone having
Yes,
doubt
sir.
Yes, sir.
Yes, sir.
6.
Okay, so R is
Yes,
equal to
sir.
6 ohm. Unknown resistor is 6 ohm. Now I am giving one example. So calculate and tell me the answer. Okay.
Yes,
I
sir.
am giving one example. Okay, I am having this 4 register. Okay, just I am taking eraser. I need one more register here. Okay, so now I'm giving the further connection like this and like this. Okay, so this is my 1 ohm. This is also my 1 ohm. This is also my 1 ohm. 1 ohm. And I'm giving 5-volt DC supply. Okay. Now you need to find current delivered by the battery. You need to find current delivered by battery. So tell me, this 1 ohm and 1 ohm are connected in series or parallel?
Series. Series.
Series.
You can see here connection is given here. This connection is given here.
Parallel.
So this is parallel. This connection is also given here. So this is parallel, and this is parallel. So all 1 ohm connected in parallel. So just I am simplifying the circuit. So I can write this is 1, this is 1. So I'm converting this circuit into this due to having parallel connection 1 ohm, 1 ohm, 1 ohm, 1 ohm. Okay, so this is the circuit diagram actually. So you can realize by this. Okay, so this is the parallel connection. Okay, so one more connection is given between this branch. So that is parallel connections. Okay, suppose I am removing
Sir,
this.
current
Yes, current is
20 ampere.
yes, current is 10 ampere. Tell me R equivalent first. R equivalent is
1
equal
by
to
4.
0.25.
0.25 ohm. Okay, 1 by 4. And current I is equal to, according to that. Are you getting?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay, want to solve one more example.
Yes.
Yes,
Okay,
sir.
I'm giving
Yes, sir.
a difficult one. Okay, I am having okay. If anyone having doubt in between, then you can tell me at any moment. Okay. So this is my 100 watt, 100 ohm, 55, and this is my 90 ohm. Okay. I am adding more connection. Just we are just only now going through only series parallel connections. Now afterwards you will be having star delta connections. For star delta, that is used for the complicated network solutions. Okay, just I need. Okay, I'm giving here 100 ohm. This is also 100 ohm. This is 50 ohm. This is 100 ohm. This is 50 ohm. And this is also 50. Now, what you have to do, you have to find out current taken by the circuit. You have to find current taken by circuit, or you have to find total circuit current. So what we will do first? Anyone having idea what we will do
Yes.
first?
Yes, sir.
Sir, that
These
50 and
are-
50 will be connected as this.
Okay, these are in series connection. These are is also in series connection. Okay, these both resistor. Are you getting?
Sir, the answer is 2 ampere.
The answer
Yes,
is
sir.
2
Answer is
ampere.
2
Yes,
ampere.
very good. What's your name?
Sir, Krish Patel.
Yes, yes, very good. Excellent. The answer is
Yes,
2
sir.
ampere.
2 ampere.
2 ampere. So
Got it, sir. 2
by
ampere.
making this summation 100 and 100, so we'll be having 200. So this 200 that is in parallel with this. Okay, this is also in parallel with this. Okay.
2 ampere.
This due to this parallel connection, we'll be having 40 ohm and 50 ohm downward side. So after this, we'll be having the circuit like this. In exam, you have to show by step, okay? By showing the circuit, you need to show the answer, okay? Don't directly just uh, show the answer. This is 90 ohm. This is 40 ohm. After finding parallel combinations, 50 ohm, and we are having here 100 volt. Are you getting up to this, everyone?
Yes.
This 40 ohm and 50 ohm that we got by series combination, that is in parallel with 50 ohm. This is series combination parallel with 100 ohm. So we are getting 40 ohm and 50 ohm. Now what we will do? Anyone?
Your phone is minute not also.
40 and 50 ohm
Okay,
are in
okay,
series
okay,
now.
okay. I made mistake. Okay, I made mistake here. Wait. This connection is connected upward. Okay. This connection is given here. Otherwise, you will not get answer. Okay. So this 40 ohm and 50 ohm are in parallel or series?
Series.
Series, because no any connection given between these two. Okay. So this is series. Okay. For 40 and 50, that is 90 ohm. So this 90 ohm and this 90 ohm in parallel. So answer is 45 ohm. Now we have a reduced diagram is like uh, this and this. Okay, this is 100 volt. This is 100 ohm. This is 55 ohm, and this is 45 ohm. Now what we will do? Anyone?
45 and 55 in
45
series.
55
This is in
and
series.
55
This
is
is in series. This is in series. Now after this series connection, this becomes in parallel with 100. Okay.
100 by 2.
So your connection becomes like this. This is 100 volt. This is 100 ohm. This is 100 ohm. Okay. Now the parallel combination of 100 ohm is 50 ohm. So now
50 ohms.
what you have
50
left
ohms.
in circuit diagram like this. This is 50 ohm and this is your volt. Now you have total R equivalent is 50 ohm and this is your 100 volt. So I is equal to V by R. So 100 by 50, that is your 2 ampere. Okay? Understood?
Yes,
Yes,
sir.
sir.
Okay, so
Yes, sir.
in example, in statement, he asked solve the circuit by using KVL, KCL, by using mass analysis, by using nodal analysis, by using star delta transformations. If asked star delta transformation and if you are solving by series and parallel, then you'll get 0 marks. Okay. So first read the statement. What examples is given and what methods are asked. So according to that, you have to go for solving these circuits. Okay. So after understanding this series and parallel combination, suppose we have complicated networks, then we are using star delta transformations. Okay. So for the complicated networks, we can't use series and parallel connection. Otherwise, it becomes complicated. So to solve complicated networks, we are using star delta transformations. Okay. So that we will do in next lecture. So up to this, anyone having doubt?
No, sir.
No, sir.
No, sir.
Sir,
Yes.
sir, in all we must be draw all diagram.
Yes. I'm not listening you.
Sir, in exam we
Exam.
must be draw diagram, all
Yes.
diagrams.
Yes. You must have to draw the diagram. Otherwise, you'll not get marks. You can't put directly answer.
Okay, sir.
Okay. So by drawing the example, by drawing the reduced form of circuit, I can understand you are knowing the methods, or you know the methods. Otherwise, I can understand just you copied from others. Okay.
sir.
So same this here the conversion is given. I have shown you. Okay. So by step by step you have to show like this. Okay. I will show, suppose the one example is given like this. Okay? Mute from your side. Mute from your side. Okay, so I'm showing some this is the example is given. So you can see here the reduced form of diagram is given. Accordingly, answer will be written. So this is how you have to solve in exam. Okay, you can see the conversion of diagram and the answer is written. Okay, are you getting?
Yes.
Okay, so in each example, the reduced form of diagram is given, and in side by side, the calculation is given. You can see here. Okay. So up to this, anyone having doubt in series and parallel connections? I will ask you.
No, sir.
I will ask you in tomorrow's lecture the advantages of series and parallel connections, the applications of series and parallel connections.
Okay.
Okay.
Okay, sir.
Sir, in parallel connection, efficiency of instrument may decrease or not?
No, it will not decrease. As
Sir, even if for higher voltage requirement instrument.
No, in efficiency that depends on your uses. If you are doing number of times switching on and off, if not required, then obviously it will decrease. And you know the life of equipment is already defined, that will last to 1 year, 2 year, but according to your uses, obviously your efficiency will be increased by monthly or yearly. Okay, but the parallel connection is very advantageous for this domestic and these power wired connections. Okay. Why your equipment? Why your equipment or why your appliances are going to damage or that expired very early? Because due to having you are not getting proper voltage or current from your area. So due to fluctuation of voltage by the grid or by your area, your appliance is going to damage. For that, you should need proper rated voltage 230 watt and proper rated current. Understood?
Yes, sir.
Yes, sir.
So due to having proper rated voltage and current, your appliances will operate with full of efficiency. But if you are getting low voltage and low current, so obviously your 100-volt bulb that will not bright that according to the given rating. Okay, so due to low voltage and current, it is compared to the its rating. Okay, so on tomorrow's lecture, we will move to the star delta transformations. So in star delta transformations, we will do star to delta transformations and we will get the equivalent resistor equation. Then delta to star, we will get the equivalent resistor equations. And I will give you some examples of star delta and delta star transformations. So according to that, you have to solve R equivalent for these transformations. So we'll be having complicated networks. So how to solve the complicated networks by this star delta transformation easily. Okay. So that I will show you, and I will give examples for your practice purpose. Okay. So any new entry students having doubt or query for today's lecture?
No, sir.
So I am ending my session here. If you are having query or doubt, then you can tell me right now. Otherwise, if you are not having any doubt or query, then you may leave the session.
Sir,
Thank you, sir.
can you do this PPT?
Yes, I will
Thank
send
you, sir.
I will send it. I will upload it on Microsoft Team. Okay. So you can just go through the file.
Okay, sir.
You will find it.
Thank you, sir.
Thank